Hello, this is Juan Moresco, and this is the first video of three on Amazon Web Service databases and analytics. So in this first video, we will cover the theoretical foundations, what databases are, the two main paradigms, and the key of AWS services you need to know. Let's start with a simple question. Why can't we just store everything in files on disk? The truth is, we can. Amazon Web Services give us EFS, EBS, EC2 Instant Store, and S3 for this base storage. But these solutions have real limitations. So when we think about databases, we are looking for three core things. The first is structures, the ability to organize data with a defined schema. The second, indexes, so we can search and query data efficiently instead of scanning through millions of files one by one. And third, relationships, the ability to link datasets together. Think like students link to courses or customers link to orders. There's also a key concept shown on this slide. Databases are optimized for a purpose. There is no single perfect database for everything. Each type comes with different features, shapes, and constraints. That's exactly what we're gonna explore. There are two major paradigms in the database world: relational and NoSQL. Relational databases look and behave like linked spreadsheets. They use tables and rows and columns, have a fixed schema, and are queried using SQL. Structured query language, they are great when your data has well-defined complex relationships. For example, a student table, a subject table, and a department table all linked together through IDs. NoSQL databases are purpose-built for specific data models and offer flexible schemas. Their main advantages are flexibility, you can evolve your data model without breaking everything; horizontal scalability, they are designed to scale out across distributed clusters; and high performance for their specific use cases. A common example of NoSQL data is JSON. Data can be nested, fields can change over time, and you can have arrays inside objects. That doesn't map well to a relational table, but in NoSQL it's completely. Before we look at the specific services, there's an important concept to understand. That is the shared responsibility model as it applies to databases. When you manage AWS services like RDS or DynamoDB, AWS take care of all the heavy lifting, like provisioning, automated backups, OS patching, high availability, monitoring, and scaling. Your focus is on your data and your application. In contrast, if you run your own database on a EC2 instance, you are responsible for everything, like resiliency, manual backups, patching, high availability, fault tolerance, and scaling. It's technically possible, but it consumes time and resources that could be spent building value for your own business. So, because of this, the general recommendation is to use AWS managed services. The first service we are looking into is Amazon RDS, that is Relational Database Service. As the name suggests, it's AWS managed service for SQL relational databases. RDS lets you create cloud databases using several engines like PostgreSQL, MySQL, MariaDB, Oracle, Microsoft SQL Server, IBM, DB2, and also Aurora. which is Amazon Web Services proprietary engine. So the advantages of using RDS over running a database on EC2 include automated provisioning on OS patching, continuous backup with point-in-time restore, building monitoring dashboards, read replicas for scaling read traffic, maintenance windows for upgrades, and store buckets by EBS. So we end up this video with Amazon Aurora, AWS proprietary database engine. It's compatible with both PostgreSQL SQL and MySQL, so you can migrate without changing your application code. The performance number AWS claims are impressive. Aurora is 5 times faster than MySQL on RDS and 3 times faster than PostgreSQL on RDS. This is because Aurora was built on from the ground up for the cloud. The storage grows automatically in 10 gigabytes increments up to of a maximum of 128 terabytes, so you don't have to worry about running out of space. The cost is roughly 20% higher than the standard RDS, but the performance and efficiency gains typically justifies that difference in production workloads. Aurora also has a serverless option, which automatically scales capacity up and down based on the actual usage. So it's perfect for infrequent, intermittent, or unpredictable workloads. So that's everything for this first video. In the next one, we'll get into the practical implementation